This one is talking about a binomial experiment. You have to figure out whether it meets all the requirements for a binomial experiment or not. The things that you want to look for are whether it's with or without replacement, whether there are only 2 outcomes or more than 2 outcomes, and whether there are a fixed number of trials. Since the experiment consists of drawing 10 marbles, that's your number of trials. So the number of trials is 10. So it meets that requirement about having the fixed number of trials. And then it's selecting from the bag with replacement. So that means that the trials are independent. So that requirement is met. And then it says it's recording the colors of the marbles. We actually have 3 different colors. So that means that if they're just recording the colors, that means there are 3 possible outcomes for each trial. That doesn't meet the requirement because it has to be only 2 possible outcomes. That means that it doesn't meet the requirements of a binomial experiment. So this is another one where it's asking you if it meets the requirements of a binomial distribution. So we want to think about those same things. First of all, we have a random sample of 12 households selected, and this is selecting from households in the US. So we do have a fixed number of trials, which would be 12, since we're selecting 12 households. And then for the independents, we're not selecting with replacement, but if we're looking at all the households in the US, that's a very large population. That means we can use that 5% rule, which says you can count the trials as being independent if the sample size is less than 5% of the population size. It's definitely going to be less than 5% in this case. So the trials are independent. We want to look at our outcomes. What they're asking is about whether the household has a landline or not. So that makes our 2 possible outcomes. So that requirement is met. And then the other one is that the probability of success is the same for each trial. So for this, our probability of success, if 42% of households do have a landline, our probability of success for each time we select one household would be 42%. So it's the same for each one. So that requirement is met also. Yes, it does meet the requirements. So we need to find the N and the P. The N is just the number of trials. The N is 12. And then the P is the probability of success on each trial. So that's 42%. And we usually want to write that as a decimal, so it would be 0.42. We want to describe what the variable X would represent. X is the number of successes. If we're counting our P as 42%, that means we're saying that a success is that the household does have a landline. X is going to be the number of households with a landline out of the 12.
Now that we know that this is a binomial distribution, we're going to find some probabilities. We're going to use these facts that N equals 12 and P equals 0.42, and that the X is going to stand for the number of successes, which is the number of households that do have a landline out of the 12. But first, we're trying to find the probability that exactly 6 of the 12 households have a landline. What we're doing, because this is a binomial distribution, is that we're using binomial probabilities. What we're using is the N equals 12, the P equals 0.42, and for this one, because it says exactly 6 of the 12 do have a landline, that means that we have exactly 6 successes. In other words, that we're trying to find the probability that X is equal to 6, because X is our number of successes. We're going to do this in StatCrunch. What we want to do is use the binomial calculator in StatCrunch. We're doing stat calculators binomial. We want to put in our n and our p down here, and then we want to make sure that we have exactly the right numbers. For the binomial distribution, we have to be really picky about this. We want to find the probability that x is exactly 6. That means we want to change this to an equal sign, and we want to make this a 6. There's our probability. If we round this to 4 decimal places, we get 0.1931. For the next question, we want to find the probability that fewer than 5 of the households out of the 12 have a landline. We're still going to use the same n and p, but we have to figure out which numbers exactly out of the sample space that this would include. So what we want to think about with a binomial distribution is that our sample space always is a list of the possible numbers of successes. It's always going to start at 0 and it's going to go up to whatever your sample size is. So our sample space includes all the numbers, all the integers from 0 up to 12. We want to figure out exactly which ones of those are included when we say fewer than 5. So if we're trying to find the probability of fewer than 5 successes, fewer than 5 means we're not including the 5, but we're including everything less than that. So this would mean that we'd be looking for the probability of 0, 1, 2, 3, or 4. Another way to say that would be that we want the probability that x is less than or equal to 4. Back to StatCrunch with our binomial calculator, I'm going to change my inequality to a less than or equal to, and I'm going to change my number to a 4. And there's my probability. Rounded to 4 decimal places. The next question is to find the probability that at least 6 have a landline. So again, we're looking at our sample space and figuring out which of those numbers are included when we say at least 6. At least means that we are including the 6 and anything more than 6. Up to the end of our sample space, which is 12. That would mean we could say we want to find the probability that x is greater than or equal to 6. That way we're including the 6 and we're also including anything greater. In StatCrunch, that means we're going to change our inequality to a greater than or equal to, and we're going to change this number to a 6. That's going to give us 0.3889 if we round it to 4 decimal places. Now we want to find the probability that at least one of the households has a landline. So this one, there are a couple different ways you could do it. So at least one would mean that we're trying to find the probability that x is greater than or equal to 1. This is very similar to what we did up here, where we were finding the probability that at least 6 have a landline. At least 1 means x is greater than or equal to 1. So we could find this directly in StatCrunch just by changing this to a 1. We still have the greater than or equal to in there. That gives us 0.9986. There's our probability. Another way we could have found this is by using the complement. The complement would be anything from our sample space that wasn't already included in this. The only number that wasn't included if we go from 1 all the way up to 12 is 0. So to do this, we could have also found the probability that x is equal to 0 and subtract that from 1. To do that in StatCrunch, we would find the probability that x is equal to 0. That gives us 0.0014. We're going to subtract that from 1. 1 minus 0.0014 is going to give us the same answer we had over here, which is 0.9986. The next thing we need to do is find the mean and the standard deviation of the probability distribution. These two are just formulas. When you go to take your exam, you need to have these formulas on hand. For a binomial distribution, the mean is n times p, and the standard deviation is the square root of n times p times 1 minus p. We already have all the information we need for both of those because we know the n and the p. For this binomial distribution, our n is 12 and our p is 0.42. If we multiply those together, we get 5.04. For the standard deviation, we're taking the square root of 12 times 0.42 times 1 minus 0.42. That's going to give us 1.71 if we round it to 2 decimal places. And that's all we have to do to find the mean and standard deviation if we have a binomial distribution. But the last question for this one is, out of the sample of 12 households, how many of them would you expect to have landlines? The key word in here is expect. What that means is it's asking us to find the expected value. The expected value for a probability distribution is the same as the mean, so we already found it up here. Now, the way they ask this question is talking about how many households. So actually, we want to round this to the nearest whole number, which would be 5. Out of the 12 households, we would expect 5 of them to have landlines.